Well, hello and welcome everyone to the 2022 Better Building Summer webinar series. We are dedicated to bringing you the latest actionable insights from leading industry experts. And this is an annual series and it's a chance to explore the topics, technologies, and trends that affect your organization, as well as efforts to accelerate energy efficiency adoption within society. Before we dive in, there are a few housekeeping points that I'd like to cover. Please note that today's webinar will be recorded and archived on the Better Building Solutions Center. We will follow up when today's recording and slides are made available for each of you. Next thing, attendees are in listen-only mode. This means that your microphones are muted. If you experience any audio or visual issues throughout the webinar, please send a message to the Q&A box located at the bottom of your Zoom panel. My name is Bruce Long and I'll be your moderator. I've been working on industrial energy efficiency since the late 1990s and supporting the DOE's Better Plants program here at the DOE since 2015. Today's topic is a very important one and one that doesn't always get as much attention as it deserves. Demand response, particularly automated demand response and demand response in industrial facilities. The idea behind demand response is something that started a long time ago, probably in the 1990s, from the utility sector, and basically to prevent from having to bring additional generation capacity online during periods of high electric demand. Power plants and utility companies started a process where they could enter into agreements with their commercial and industrial customers to reduce those customers' electricity demand at peak demand times. There are a variety of demand response programs available to both industrial, commercial, and residential end users today. And in today's webinar, we'll be discussing some technical resources, especially a new document that we generated on demand response programs in manufacturing, but we'll also provide two compelling partner examples of how to leverage demand response to maximize the benefits to their respective organizations. The demand response in industrial facilities, peak electric demand, is the document that I just referenced, and there's a link to it in the chat box right now. This document offers actionable insights into demand response programs, various electricity rates, and ways you can benefit from participating in your utilities demand response program if they offer them. In addition, we will have the lead author as one of our presenters. So hopefully you'll get a lot out of that. On slide 5, the Slido instructions today, we'll be using an interactive platform for question and answers, polling, and feedback. This is called Slido. Please go to www.slido.com on your mobile device or on your computer and open a new window in your internet browser. Today's event code is #DOE in capital letters. If you would like to ask our panelists questions, please submit them anytime throughout the presentation. We will be answering your questions near the end of the session through the Slido. You can also select the thumbs up icon for questions that you like, which will result in the most popular questions moving to the top of the queue. Also, this is in Slido. So before we get started, we want to learn a little bit more about you. So we're going to start off with a few polls. Please join us over at Slido to respond to the following questions. If you're having any issues, please message our tech support team by using the Zoom Q&A function. So the first poll that we have is who is responsible for participating in demand response programs for your organization? We'll give folks a few more seconds before we close the poll. Like that, nobody. Okay. Well, it looks as though we've gotten a good number of responses, and it's interesting that a lot of folks have chosen the energy manager. We found that this can sometimes be the purview of somebody else within the organization. So it's also the case that, as we can see from these answers right here. So I think we'll go ahead and finish this poll and start with the next one. And the second question is, what technologies have you or your colleagues leveraged to maximize the benefits of demand response for your organization? This is, again, a word cloud. We'll get some good responses here. Okay, we'll give folks just a few more seconds. Looks as though there's quite a variety of strategies and technologies here. Okay, well, I think we've got a pretty good group of technologies here. So thank you very much for participating in these two polls real quick. Next, I'm going to go ahead and start introducing the speakers. I'll go ahead and introduce one at a time. And then if you can save your questions for the end, we'll get to those at the end. Our first speaker today is Ms. Paulomi Nandi from the Oak Ridge National Laboratory. Paulomi is engaged in DOE's Better Climate Challenge, a Better Plants program. She helps develop resources and tools for greenhouse gas accounting and also helping Better Plants partners develop decarbonization roadmaps. Paulomi is also a technical account manager in the Better Plants program, and she is the lead author of the demand response document. So I hope you'll get a chance to view that document. And now I'll turn it over to Paulomi.
Good morning, everybody. Thank you, Bruce, for the introduction. Next slide, please. If you can go to the next slide. Okay. Using this guide, as Bruce mentioned, that I have me with my colleagues, Thomas Wenning and Alex Botts, has developed this resource for our industrial partners specifically. So peak demand management is usually peak demand charges for industrial facilities is usually very high. Every industrial facility in some way or the other can deploy some form of demand management to help curtail their peak demand charges. So in this guide, basically, we kind of explored the different time varying rates that are available from your utility provider, understand how you can use different strategies to kind of deploy demand management responses in your facility. And then also I have a couple of case studies that we have asked our partners to share with us as part of this guide. Next slide, please. Let me jump into things and talk a little bit about how electricity is generated. Electricity, as we know, is generated from different sources. It can be fossil fuel or renewable energy. Because there is no capacity on the grid to store this electricity when it's generated, it's always generated and directly distributed to the customers. For this purposes, there are different base load and peak load plants. Base load plants are there. Basically, they're operating all the time, and peak loads come online when there is a higher load demand on the grid. And so the basic idea is basically for the facility to start thinking about how to reduce their peak during these peak hours. Next slide, please. Quickly going over just the general understanding of electric consumption and electric demand. Electric consumption is total electricity that's consumed in a facility, while electric demand is rate at which electricity is consumed. As you can see in this figure here, throughout the day, there are different times during the day, the number of lights that are turned on. And during 12 p.m. in this graph, you can see all the lights are turned on. So basically, for this case, the electric demand for this facility, if you might say, is 500 kilowatts, whereas the total energy consumption is 1.8 kilowatt hours. Next slide, please. So as I mentioned, all facilities can take part in DR response in some way or the other. For some, it might be easier. Some, it might be a little more difficult, depending on how they operate and the flexibility of their production. Candidates who have more flexibility in their production schedule and process timing, they are much easier candidates, and they can easily deploy some form of DR, demand response. Whereas facilities who are continuously near their processing capacity and have higher volumes of production, it's difficult for them to do DR response. But there are still some strategies they can still use to kind of help them curtail that demand charges. Next slide. There are two different types of demand response, seasonal demand and daily demand. Seasonal demand is varies more with the weather patterns in United States. So here you can see in summer, and I know the fonts are very small, but you'll get a slide deck so you can see it later. But in summer, basically, you have a higher peak during the day when the cooling requirements are higher on the grid, whereas the winter peak is slightly lower because winter demands are mostly driven by natural gas usage. Whereas the daily demand, it's very specific to an individual facility. Here, for example, you have a graph here showing a customer facility where the peak demand is around 640 kilowatts. During the early hours of the day, it slowly ramps up. And then during the day, around afternoon, it reaches its highest peak. And then during the later evenings, the load slowly ramps down. The average load for this facility is around 210 kilowatt hour. So you can see there is a wide change in the average load that you have, and then the maximum load, which is your peak demand. Next slide, please. Jumping into a little bit of time varying rates, there are different time varying rates that are available from your local utility provider. Some of them I have mentioned here. So time of use pricing, this is basically a rate structure depending on on-peak and off-peak hours. This is predetermined by your local utility. And usually during the afternoons, you would see a higher rate, higher charge, depending on where you are located in the United States. The bill volatility and the savings you can also see are marked by those stars. The lower number of stars shows lower volatility and savings, while the more number of stars shows higher change in that. The next one is peak time rebate. It's basically customers get a rebate when they reduce their load. When there is a higher peak on the grid. Bill volatility for this is none because customers has very low, they don't get penalized being part of this, and they have higher savings. Critical peak timing, peak pricing is similar to time of use pricing, but the cost during that hour is slightly higher than what you would expect for time of use pricing. Next slide, please. Coincidental peak demand is something that customers in ERCOT or PGM should be a little more cognizant about. This is basically when the facility is at the same time peaking when the grid in that area is peaking as well. And so during those hours, during the summer months is usually when this happens, and customers should be cognizant and think about how to curtail the load during those summer hours. These charges can be really, really high than your normal time of use pricing or other pricing schemes. Variable Peak pricing is basically similar to time of use pricing, but basically what happens is the cost varies during even those hours. It's not a constant cost. Real-time pricing, it's literally a dynamic pricing rate, where it almost mirrors what the rate structure is in the wholesale electric market. Next slide, please. Demand response strategy. What are some of the strategies that you can use in your facility? So basically, this shows an example facility where you have different areas inside your facility. So you have office spaces, critical operation areas, shop floors, warehouses, as well as equipment room and office spaces. So you can use basically manual adjustments to kind of change the set points, things like that, to kind of help you manage that demand. Or you can use occupancy sensors or your BMS system, building management system, which can help you kind of curtail that load. Your BMS system basically would get inputs based on weather, utility demand, even your renewable, how much renewable you're producing on site. Those would feed into how you would basically manage your load inside your facility. This would be something that you would do at a daily basis. So it would be a continuous demand management. Say, for example, you get an event that is triggered on your grid, and you get a notification from your utility provider or a third party who is helping you kind of manage your demand response program. You can go ahead and can manually adjust these set points, or you can turn off equipments if that are not critical for your operation. So that would be something that you would do for an event-driven event. Next slide, please. Here we talk a little bit about the hierarchy of demand response. Hierarchy is organized by a method which will give you the greatest impact on your facility's demand requirements. Eliminating load would be most drastic to reduce load from the grid. The next would be reducing your load through energy efficiency or other ways. Moving your load or substituting your load. As you go eliminate your load, you get the highest load adjustment, whereas if you put generation, you have the highest growth potential. Next slide, please. Energy efficiency. So here we kind of go into demand management strategies. So load shifting, shedding, and generation. Shifting would be either using storage, shifting cooling loads, shifting equipment charging. Load shedding would be, again, HVAC setbacks, dimming lights, turning off plug loads. Or generation, you can have on-site generation either through combined heat and power, on-site renewables, something like that. Automated, next slide, please. Automated demand management, as more and more market becomes wider for Internet of Things, advanced building management system. This has become more and more something that customers are slowly looking into, where they use automated demand management to help them curtail that load. They use third-party provider to help them kind of also identify where they can curtail some of their loads during peak demand. Next slide, please. Finally, I want to talk a little bit about the case studies that we found from our partners that they did. First one is Cleveland Cliffs, where they had partnered with their curtailment service provider and had committed to reduce their peak load between 30 to 120 minutes, basically getting a heads up before. And based on what production and schedule and hours of the day, they basically curtail their loads. And the next one is AgriPure. Basically, they have been taking part in electric and natural gas demand response program for over 14 years. When they get notified about an event that's happening on the grid. What they do is they basically go out and manually adjust their set points, turn off equipments to kind of curtail their load. I think that's my last slide. Back to you, Bruce. Here's the link to the document, and I think it's in the chat as well. If you have any questions, feel free to reach out to either me, Bruce, or Alex, who is also an author for this document.
Great. Well, thanks, Palami. And just make sure everyone realize these are not future webinars. These are just the links to the document and the people who worked on that demand response document. So, well, next, I'll go and introduce our next speaker. It's Jesse Tutel, who is a senior manager of energy analytics at Lineage Logistics, which is the world's largest and most innovative temperature-controlled industrial real estate investments trust and logistics solutions provider. In this role, Jesse works on optimizing Lineage's energy portfolio with an emphasis on new technology development and energy market strategy for the company's 400+ sites across the globe. As part of the R&D team, Jesse has shared multiple awards and patents for work on novel energy initiatives, including US DOE's Better Practice Award for the last 4 consecutive years. I should point out that Lineage Logistics is also a Better Plants Challenge partner. So we've definitely learned a lot from them, and they've leveraged some technical assistance from us. So Jesse, take it away, please.
Thanks, Bruce. Hi, everyone. Thanks for joining today. I'll start off on the next slide here with just a brief introduction, or sorry, next slide, one more, into who Lineage is. So we're essentially the time machine for the cold storage food chain, right? There's a big time lag between when food is grown or produced, meat, poultry, agriculture, whatever it is, and when it gets distributed to grocery stores and consumed by families. And that's when it enters the Lineage part of the supply chain. We store food at various temperatures, typically below 0 degrees Fahrenheit, and keep it, safe and ready to eat whenever it's needed during whatever time of year people consume it. Next slide. As Bruce mentioned, we have over 400 sites, and now I think over 21 countries. This slide is slightly outdated. We continue to grow. Just to give you an idea of our kind of footprint, and today I'll be focusing on our US efforts regarding demand response. Next slide. I'll briefly touch on this just so everybody understands. Bruce kind of mentioned it. We like to leverage technology analytics. We have an applied sciences team, which is growing pretty steadily throughout the years. That's where I sit on the research development side. That touches every aspect of our business, including labor and transportation optimization. But just to set the context for today's talk, that's kind of the skew that I bring to my perspective on energy. And I just encourage everyone here to embrace the power of kind of data-driven decision making, data availability. And I got a couple examples of how we've managed to leverage that over time. Next slide. So the reason we can have a data science team is because we we lash our value to the cash flow of the company. So for us, we're looking at the top equation here. It's pretty simple how our business operates. We provide various services, typically cold storage, at a given price. So it's the price we can charge for a service times the number of times we can do that service minus our 2 biggest cost centers, which are labor and power. And EBITDA here represents our net profit, essentially. And then within power, how we think about power cost is just like driving a car. We have a certain amount of thermal work we need to get done. That's heat removed from the product and from the room. That's the number of miles we have to drive on a road trip. Then we have how efficiently are we using gas? How efficiently are we using the kilowatts electrical that we draw from the grid or any other generation source to achieve that kilowatts thermal work, just like miles per gallon. And then what are we paying for gas? And for us in energy, that's how are we procuring energy if we have a choice in a deregulated market, for example, and when are we procuring it? So, Palombi touched on hourly differences in the price and the effect that has. And then last year we signed the climate pledge. So now we have an additional kind of objective here where instead of power costs, we're also looking at emissions. And really the only thing that changes here is carbon, right? And in that last bit there, replacing price. And to Palombi's point, it's nice that these things tend to be aligned. They're not always aligned, but there's a high correlation between the price you're being asked to pay and the carbon emissions of that generation source. When the grid is most stressed out, the price is highest. And then as you reduce, at that point, you're saving money, but you're also incentivizing, the grid to not use high emission sources, and you can reduce your carbon footprint. Next slide, please. So we have examples that, this is kind of going through the demand response hierarchy that Palomi mentioned. For the sake of time, we'll just discuss two sections here, the scheduling section and demand response. Next slide, please. Specifically, scheduling, talking about shedding and shifting, load shedding and shifting part of that kind of that mechanism. So cold storage is somewhat unique, and this won't apply to everyone, but this is the use case that we developed pretty early on. The industry standard for cold storage, and again, keeping food below 0 degrees Fahrenheit here, is a thermostat control system. So when the building gets a little too warm for comfort, you click the giant refrigeration system on, which uses about 80% of the power in a given site, on average. And as it gets cold enough, you turn it back off. And so you have this kind of on-off control. So you're using relatively consistent power throughout the day, despite there being inconsistent prices throughout the day. And so you end up paying, more for the power, during peak hours. And so this concept of thermal flywheeling that we developed is pretty intuitive, right? You use power when it's cheap, and you don't use power when it's more expensive. And there's a lot that goes into developing that ability to achieve that, but that's the basic concept. Next slide, please. This slide, without going into too much detail here, the thing to stress here is to figure out how your building reacts, right? When you do things to it, when you turn it off, if you Palomi mentioned there's certain businesses that are well designed for demand response. We happen to be one of them. But understanding the impact of your processes to your production, to the building, to the building load, that's all critical. And for us, modeling out how our building reacted generated some pretty significant insights. And so this is a fit. The dots are what we predicted what would happen, or sorry, the line is what we predicted would happen here when we cooled for 15 hours and then let it just warm up for 8 hours. And you can see that fit, exactly with the data points we actually collected. And the insight here is that we have a giant thermal battery. Cold storage is the biggest thermal battery in the entire world. And this looks exactly like a battery charging during the cooling period and then heating up during the warm period. And we can leverage that, next slide, please, to actually predict, kind of control our load in a very mathematically rigorous way, right? So this is where we get into a bit of that data analytics and optimization, through a lot of stuff that I'd be happy to go into. We can kind of optimize based on what we know about the energy pricing, how we use power, right? So this is a load shedding example. Here we have on the top plot the power that the site is using at the compressors, and that's again a large proportion of how much energy we use. And then you have the usage rate in dollars per kilowatt hour in the bottom panel. You can see we're dropping load. This is the earliest example. This happened in 2018. Dropping load when the prices are increasing, using load when increasing load when the prices are dropping. And this is also a demand mitigation effort, right? Because we don't want to spike a new demand charge, as we recover from those low periods. And so it's a bit of shedding and shifting. Next slide, please. One of the other highest energy processes we use is blast freezing. So warm food comes in from the field or wherever it's produced, for example, gallons of strawberries, and we have to freeze it from ambient, 70 degrees Fahrenheit down to 0 degrees Fahrenheit. And so we just put it in this big, essentially closed room box, with a bunch of pallets, and just turn this thing on until it's frozen. Next slide, please. And one of the biggest insights we had was how we can control that process. Here you have a simulation of a box of food surrounded by a layer of air freezing over time. And there's a physicist on our team, so that's why it's in units of Kelvin, but the green spot is frozen, essentially. And this process typically was just on, right, like I said, until it's done. And that's typically, anywhere between 24 and 72 hours. But what we've been able to do is leverage the ability to simulate how the food responds and accurately measure how the food responds in testing to pulse that process, right? So we can achieve very similar results on very similar timeframes, but without the extreme energy usage that process uses. And so we can leverage that for demand response. We can leverage that for, just kind of peak demand management as well. Next slide, please. Now onto demand response specifically, responding to the grid. Next slide, please. Here's some summary statistics of how our company does this in the US over the last couple of years. I'll spend a little time on this to let everybody digest some of these numbers, but from 2020 to 2021, again, these seasons run from June to May in the vast majority of markets. That's why it's organized that way. We've gone from about 47 sites enrolled with about 30 megawatts of demand response availability, up to 99 sites that we're planning for this coming year, which just started this month, and over 74 megawatts. And so this is a growing, a growing market for us. We participate in pretty much every market we can. With our 200 plus sites that we have in the U.S., we still have more enrollments to make in the coming years. And some of these states don't have response programs because for various reasons. But we're in 16 states, and this is our current footprint. And some estimates of carbon reduction there. These actually should be higher because it's using average offsets of the grid. And when demand response occurs, that's typically higher emission energy sources. But you can see that you have a pretty major impact when you actually reduce load on the scale. And so, just wanted to briefly talk about some of the factors. We participate in a lot of different programs, and I kind of am going to focus on going forward, how easy they are to do, what it takes to get them done, and then a few things to just consider for yourselves. Is it a manual response program? Are you sending an email, a call? Someone on site is kind of turning knobs and doing this themselves. Preset is the way we kind of think about it. Some people refer to that as automated, but really that's just a protocol in your control system where they can press a button, right? And then hit a preset schedule ramp down procedure in order to achieve demand response goals. And then automated. And automated to us means without having the manual intervention of someone at the site actually initiate the shutdown. That's something that I'll get into in a moment. And then, some other things that Plummy touched on, how often, how much notice do you get ahead of time? How often are these going to occur, and how much time do you have to respond once these events are called? Are all really important factors in terms of kind of deciding which programs you're actually going to be in. Next slide, please. So I'll start with the manual. One of the ways that we have had success, with manual response, meaning that the site level guys are getting some sort of notification, and they're the ones manually managing load down for a demand response event. It's just through data availability. I saw a lot of you in the poll, said sub-metering, and kind of that just aligns with data visibility. That's kind of a prerequisite for this, in my opinion. If you can understand what your load is, then you can manage your load, right? It's a measure to manage problem. So we have things like this dashboard on the left where we're showing, what the load is for the different compressors in the building at the main services. And then an expected price, in the day-ahead ERCOT market. That's not what we actually experience, but it's an indicator. And then you can and then there's also these automated alerts that we send out to people, right? And typically, the high price hours are indicative of grid stress. That's a potential time you might have a demand response issue come up. Next slide, please. This is an example that I don't have a ton of time to go into, but essentially on the top plot here, you have an additional opportunity of when you do demand response events, you have an energy arbitrage opportunity. Here, and we have the power that the facility is using in black, and those dashed lines on the vertical are demand response events. And we have these hedges, and it's a deregulated market where you're procuring power ahead of time at a fixed contract price in deregulated markets. When you drop load below those hedges, as you can see, that's highlighted in the green in that plot, you're liquidating that unused hedge back to the market. So when we're responding to these demand response and vertical dashed lines, we're also selling back unused energy at a big arbitrage opportunity. And so there's lots of ways to kind of align incentives and value stack these programs. And that's kind of just what I'm showing here. Next slide, please. I can come back to this later in the questions if we have more time. Last thing is controls. And wrapping up on this. This is called the Atlas platform. It's by a company called Crossno K, CROSSNO KAYE. And this is how you get to actually automated demand response, where you have, inputs coming from the market passively, price inputs, any pre-programmed response that you want. And this can automatically achieve that, demand response in your facility without the guy having to go press a button or without the guy actually having to go turn knobs. Next slide, please. Next slide, please. Skip this one. We're out of time here. And then this is just kind of how we view the future of it, right? This is all the inputs into a single facility that we might have. This is our future state where you have, so any on-site generation on the left, battery storage, all the market signals and thermal state of your building. And this is all just going into a big optimization blender. And ideally, this is an automated process for us going forward. And that's it. Next slide, please. I'm done.
Great. Well, thanks a lot, Jesse. That was really interesting. And I particularly like the way that you've got PV and on-site generation in this last diagram, because that may be one of the things that can help with the demand response is that if you have more insolation at the height of the day from solar, that can reduce the load for the utility. Anyway, next slide, please. I'm going to introduce our third speaker. And today we have Joe Benyon. Joe is a mechanical engineer with the Los Angeles Department of Water and Power. He is also a Better Plants Challenge partner. Jesse is currently the supervisor of water operations, pumps and wells, Metro Group, an engineering group within LADWP that oversees capital improvements and maintenance activities at the 49 pumping stations across the Los Angeles metro area. One other interesting thing about LADWP is that they're a municipal utility. So the water division actually buys power from the power division and so forth. So there may be a little interplay there. Jesse or Joe, go ahead, take it away. Thanks.
All right, thank you, Bruce. Good morning, everyone. So as Bruce mentioned, my name is Joe Benyon. I'm a mechanical engineer within the Los Angeles Department of Water and Power. Next slide, please. And today I'm going to talk about how our water system operations contributes to our grid support. Next slide, please. As Bruce mentioned, we are a municipal utility. We're actually the nation's largest. We consist of a power system and a water system. So the water system does end up purchasing water from itself, from its brother. And so we provide water and power services to over 4 million residences and businesses in the city of Los Angeles. We have over 8,000 megawatt electric capacity on our power side. And on our water side, we supply 435 million gallons of water to customers each and every day. Our service territory is the entire city of Los Angeles, which spans approximately 465 square miles. And to provide water and power to all those people and to the businesses, we employ over 11,000 people. So we originally began serving water to Angelenos in 1902 via the Los Angeles Aqueduct. This is a 334-mile long aqueduct that kind of an engineering and surveying feat of the time, because its designer, William Mulholland, designed it to be entirely gravity fed, which pulls water from the upper Owens Valley along the Eastern Sierra and brings it all the way down to LA without a single pump. So we're designed even over 100 years ago to be as efficient as possible. A few years later, Ezra Scattergood worked with William Mulholland to open the first power plant along Los Angeles Aqueduct and began supplying power to LA in 1916. Next slide, please. So to talk a little bit more about our water system, you can see at the bottom of the slide, we actually provide water from our source water. We treat it, distribute it, pump it, and then ultimately it goes to our customers. So we have a diverse water supply portfolio that consists of water from our LA Aqueduct, purchased water from the State Water Project and Colorado River Aqueduct, and we also produce groundwater from our groundwater basins. We own and operate all of our horizontal and vertical assets involved in delivering potable water to our customers. And since we span over 465 square miles, we have multiple pressure zones, 113 to be exact, to provide this sufficient pressure for our customers and for fire protection purposes. To support these zones, we have 86 pump stations, which I oversee, I think 49 of them. We have 325 regulating stations, 120 tanks and reservoirs for water storage, and 35 treatment facilities across the city. We also have a huge distribution network of 7,300 miles of distribution mains to provide water to all of our customers. And our main mission within the water system is to provide our customers with reliable, high quality, competitively priced water in a safe and environmentally responsible manner. That's where demand response comes in, because we want to be environmentally responsible in our own production, but also in helping our power system shed loads as much as possible and avoid turning on peaking plants during high demand times. Next slide, please. So our entire demand response program is built off of how our system operates with our system pressure zones. We designed our water system to be as efficient as possible. So we use our topography to our advantage and try to move water from zone to zone with our reg stations that operate primarily off of hydraulics and consumes minimal power when in operation. So our demand response program targets energy intensive facilities like our pump stations. So we have two primary types of pumping strategies within our system. We have closed system pumping and tank storage. Closed system pumping is ideal for smaller service areas with low water demand. These areas typically use small pneumatic tanks or VFD-driven pumps to maintain pressure in these zones. That means with low storage, these pumps are in near continuous operation, so they're not really a good candidate for demand response. Our second supply strategy is tank storage. The majority of our system zones are supplied by one or more tanks or reservoirs, and those reservoirs provide plenty of capacity to meet our large demands over hours of time and meet fire flow requirements. To fill these tanks, we utilize pump stations to pump water from lower system zones to higher ones. Once the tank is full, pump shuts off and remains off until the tank needs to be refilled. We call this type of operation block flow. Stations that operate in block flow are ideal candidates for our demand response program. Next slide, please. So our water system began participating in the demand response program back in 2016. Our goal was to reduce the demand of our generating stations during peak times of the day on the hottest days of the year. As you're probably aware, Southern California keeps getting hotter and there's more fire. So we're trying to be as economically and environmentally responsible as possible. So we want to make sure that we shed those peak loads as much as possible. So during our 2016 benchmark, our water control group determined that 17 of our pump stations and zones, over 20 pressure zones, could actually provide enough storage to be able to not operate during those peak times. So our demand response manager provides 24 hours of notification to us of a demand response event that typically lasts anywhere from 2 to 6 hours and requests our participation. At that point, we normally comply and say that we're going to be participating, and our water control group and our operators fill our tanks and reservoirs to the maximum capacity on off-peak hours so that we have sufficient capacity to meet our demand, our water demands. I'm using demand a lot, but our water demand during this peak time. And that way we don't have to run our peaking plants on the power side to run our pump stations. So that being said, our primary goal on the water system is to provide water to our customers and for fire protection. So in the event of emergency, our demand response program is flexible enough so it allows us to start pumping during those response periods, just in case if there's an emergency, so that we can ensure that we continue to provide water to everyone in need. That being said, that rarely happens, so we're able to comply and leave our stations off majority of the time. And just as a quick fun fact, our water control group and our operations has been doing a form of demand response for years, even before we began participating in 2016. Our controls group looks at the system and, any hot day, we typically try to crowd our tanks before the peak heat, just to make sure that we have enough water in our tanks for emergencies and for fires. Next slide, please. So just to get to a little bit of the results from the data that we've collected for the last 3 years, we aim to offset 4,000 kilowatts per event to support our power system. And our data has shown that we average offsetting 7,100 kilowatts per event, which far exceeds our commitment each year. And we found that we've shifted over 388,000 kilowatt hours of energy overall in the last 3 years, and avoided over 100,000 pounds of CO2 emissions by reducing the need for our power system to run peaking plants during our hottest days, which results in about a 27% emissions reduction. So that does it for my presentation. Thank you.
Great. Well, thanks a lot, Joe. That was a very good presentation. Hopefully folks got some good ideas and insights out of it. Next, we will turn to the Q&A portion of today's webinar. So I want to thank all of our panelists. And if you haven't done so already, just a quick reminder, join us over at www.slido.com. Use event code #DOE to submit any questions. And I believe we have questions here. Okay, great. So the first one that has 4 likes is that there's been a big push for electrification for carbon reduction. Do you think these programs will become more prevalent as we force more load onto the grid? Is this something we should focus our efforts on before we electrify? I'll let any one of the panelists start with that. Paulemi, maybe you want to take it on, or Jesse, or?
Sure, I can take a quick stab at that. So I think, yes, with more and more push for electrification, more and more facilities are starting to think about their capacity, think about like how they're gonna tackle that demand. And it would be a good time to start like discussing that internally as well as with your local utility provider, and see what kind of different programs that they have, and what you can leverage as well.
And I'll just tack on there. We're getting a big push from that, especially in Southern California, for a lot of the trucks and the refrigeration units on those trucks that are on our sites. That's something we're actively pursuing. I think that the best way to think about it is, an incentive now is likely to be a penalty later, right? The regulation will continue to move forward, and I think a lot of other states will follow California's lead on that front.
I'll go ahead and ask Paulemi to address the question that's directly addressed to her here. Can you touch more on the NG demand response program?
Sure. So my paper, the resource that we developed mostly kind of focuses on electricity, but there is natural gas demand response as well. If you are located in colder regions like Minnesota or say Northeast of America somewhere, there are natural gas demand response as well, where during winters you are kind of called upon to reduce your natural gas loads, as I have briefly touched on, like Agripure was doing, where they had to reduce, because they were located in Minnesota, they had to reduce their natural gas usage during those hours. It's becoming, it's not as prevalent as electricity demand response, but it's still there. And if you are in those locations, it would be good to kind of talk to your, again, utility provider and see if you can take part in it, reduce your load during those hours, because those disruptions also affect the customers as well.
Great, thanks a lot, Paulemi. The next question that has a lot of likes on it is, do you know of rebates or grants to help install smart demand controls for industry? I have to admit, I'm not aware of it, but I don't know if any of the panelists care to address that, or?
Yeah, I'd briefly touch on it. It depends entirely on the utility you're talking to. We're fortunate to have a big footprint, and there are several utilities in the country. Southern Company tends to be one. PG in the Pacific Northwest is another one. California has had conversations about this as well. For just a couple examples, in terms of how you can frame the net benefit of the controls, and then kind of reframe the conversation as an energy efficiency project, right? For a custom rebate, or for some of these utilities have existing rebates that you could apply to controls.
I don't know, Paulemi or Joe, if you care to weigh in on this one, or?
No, I think I agree with Jesse. The best information you can get, or resources you can get, is like talk to your local utility provider, because it's very customized to your local grid, local utility provider, what they have. That would be best place to start.
Okay.
And sorry, Bruce, one more thing here. A lot of times the vendors have this network, right? If you're talking to a vendor about those controls installations, they're the ones that have the relationship with the utility, or deeply understand that process, so you can leverage them as well.
Perfect.
I'll just mimic both of them. Just reach out to your local utility to see what sort of programs and rebates and grants are available for your industry.
Okay, thanks a lot, Joe. There's one that's specifically addressed to Jesse, and that is, was installing the automation software a hard sell to management, and do you use it at all your facilities?
Yeah, so it's a good question. Short answer is yeah. Change management is always difficult, and you have to make a pretty bulletproof case for a lot of stuff. But that's where you get into, just leveraging the data and just making it a pretty airtight argument for the results. We tend to approach this stuff as a proof of concept, meaning at one site we show it works, then a proof of enterprise where we show it works at a diverse set of sites, call it 3 to 5 sites, and then you can scale it. And so right now we're kind of in the process of scaling, because we've shown that it works at that proof of enterprise level. You know, money talks, data shows it, right? And that's pretty much how we approach everything. And we do have, we have a gambit of some sites with the advanced automated controls, some sites with those kind of preset, response controls, and then still many of our sites are manual, but waiting in line for that upgrade.
Okay, great, thanks. And I don't know, Paulemi or Joe, if y'all want to add anything to this, if it pertains to you as well.
I think I'll just add quickly is, as Joe mentioned, like use maybe one or two sites as like those pilot sites and see what the benefit is. That way you can get like some of those champions out and you can learn from them. So I think that is a good place to start. Again, depending on where you are, what kind of demand charges are there in your facility, like doing basically like a utility analysis, how much you're paying would be a good place to start, and kind of those might be a good candidate to do some pilots and see. And then it just becomes a better case study to sell for your upper management.
Okay, great. One of the next questions that had a lot of likes was, how do I know if I can benefit from a demand response program? Is there a resource to check, see if I'm eligible? I would imagine this depends on where you are in the country and what your utility offers, but I'll let the panelists weigh in.
It looked like I was talking, but I was on mute, sorry about that. Leveraging, again, vendors in a lot of the deregulated markets, ERCOT, PJM, they're going to want to be your market participant or your broker for this process. They can do the analysis for you. Other than that, just communicating with your utility provider or your utility rep is the best way to just go about figuring all this stuff out and doing that sort of analysis.
Okay, great. Does anyone have any advice on persuading the higher ups about the significance of submetering for data collection and visualization? Some folks seem to be hesitant because of the upfront costs, and this is a perennial problem what we've seen for a lot of submetering and other instrumentation type devices. So whoever wants to take it on, go ahead.
Yeah, I'll take a stab just because we've been on that walk for many years now, and we're on the other side of it now, where our company just universally accepts the power of data-driven decision making, but not everybody starts there, right? I think the most powerful thing you can do is lash it to future initiatives, right? Why do you want the submetering? Looking at it for the sake of looking at it is can be useful and great, and for accounting and just kind of general management practices, but do you have initiatives that will leverage those data in the future that can save money? Can you just use the submetering to save money by itself, right? I showed a picture of kind of the manual response warehouses we have, where if the site is aware of its energy usage, right, that's the step one to being able to respond to programs. You can lash it to a demand response program revenue, for example. And I think just adding and outlining the value of that data is important.
Paulemi or Joe, if you have anything.
I'll just add a little bit to that. Is basically submetering not just helps with demand response, but helps with multiple different things. As we are talking about, like just understanding where you're using your energy, when you're using that energy, just helps you kind of drive energy efficiency, drive carbon initiative, energy, like if you're doing switching, whatnot, like everywhere right now, there's a push for submetering, or there should be a push for submetering, just because you have better data to inform and have accurate information to present to your higher management. So it's not just for demand response, it's for everything. You need that accurate data.
It's a measure to manage problem, right? If your leadership is unhappy about the cost of energy, and they're not investing in submetering, then they can't really complain about the cost of energy because you have no tools to help reduce that cost.
Then another question that seems to have gotten a lot of likes so far here is, what options do you have for manufacturers that are operating 24/7?
I'll go again here, sorry, hop on all these first. There are many processes like this, and it really comes down to optimization in my view. So if you have all the inputs you need to understand, hey, this is the cost, this is what we're losing out on when we reduce our load, right, for a demand response event. and you know the value of the demand response revenue stream for you, or the saving stream, then just make that a computer problem to solve. Honestly, what's the current cost of shutting down, and is it worth it? And then you just iterate through that, and that's pretty much all you can do. And then obviously focus on other initiatives to just drop your load in general, right? Energy efficiency projects, things like that. But yeah, it just has to be a real-time data-driven decision.
Yeah, and I mean, just to kind of add to that and to expand upon, your energy efficiency, you have all these programs and rebates available right now to be able to make your facilities as efficient as possible, such as switching to LED lighting, occupancy sensors, like Paloma mentioned in her presentation, trying to do that just to reduce the overall load as well, which will help your overall operating costs and power costs.
Yeah, exactly. It's like there might be some areas in your facility that are not always there. Like you might have offices in some areas, or you might have warehouses. Like those are not always being operational. There are not always people. If there are certain areas that you can at least do some kind of like occupancy sensors or VMS system that kind of controls and turns off and turns on and setbacks stuff, that's also something. So it's just depending on how you're using the different areas in your facility.
And just
also, sorry, Bruce, one more thing. I also think that, on-site generation and batteries, right? Invest in capital assets that can help you manage load, specifically with demand response, but just in general, if you're just have a steady state load that you always need to keep on.
So that's what I was going to ask real quick, Jesse, is do you think this is where storage could help reduce demand loads for companies that run 24/7, for example? But
yeah, absolutely. I mean, that's if you go talk to a battery vendor, that's going to be the first thing they talk about, right? Is demand charge management and that load, shed away from those peak times. We've invested heavily in on-site generation. We're on track to be, I think, the third largest commercial industrial developer of solar by the end of this year. We have batteries, we have generator, that's a big part of our portfolio. And so we see the value in that and encourage others to look at it as well.
Okay, perfect. There's one question here that has been hanging around for a while, asking if a similar document will be made in the future, focus on residential or commercial spaces. Short answer is I'm not sure. I personally think that this would offer a lot of value for commercial and non-industrial end users. So I think we'll use this as a suggestion to take under advisement and see what we can put together. So, I'll go ahead and take one last question because I know we're running close to the hour. And this question here is there a point in solarized buildings? I guess those are buildings that use photovoltaic solar panels to get electricity, where the electricity demand becomes less of a concern for the actual residents and other building users?
Generally speaking, I'll touch on this, at least in California, a lot of the sites or a lot of states with a lot of solar are starting to see this power curve, right? The duck, the belly of the duck, the neck of the duck, where solar can help, reduce energy costs during, when the sun is up, but you're seeing the peak times occur in the evenings when the sun's dropping down. So, in general, there's still a need for some demand management when the sun's dropping. Yeah, I think that should be addressed for solar buildings.
Melanie or Joe, anyone before you jump in? Okay, terrific. Well, I think this concludes the question and answer session for today. We've got to keep on schedule, so I'll just go over a few closing remarks here. This webinar has been part of the 2022 Better Buildings webinar series. And as you can see, we have a great lineup of webinars all the way through the middle of August. We encourage you to sign up for these and attend these webinars. The next one will be on June 28th, and it'll be titled Clean the Air, Healthy Indoor Air for Businesses and Tenant Spaces. So we encourage you to join this webinar, learn ways that small business owners particularly and building managers can ensure healthy indoor air quality for staff and customers. Our next slide deals with the progress report. So each year, DOE releases an annual report with key findings, updates, and metrics from the Better Buildings Initiative, and that includes Better Buildings and Better Plants partners, challenge partners. So please visit the Solution Center to explore the 2022 report and learn how DOE and other partners are working for a more energy efficient future. And with that, I think it comes to our last slide. I'd like to thank our panelists very much for taking time with us today. I'd also like to thank the attendees for staying as long and for asking so many good questions. Feel free to contact these presenters directly if you have additional questions or if we couldn't get to your question during the Q&A period. I encourage all of you to follow the Better Buildings Initiative on LinkedIn and Twitter for all the latest news and social media content. You can find our handles by their respective icons on the left-hand side, on the left half of the slide. And you will receive an email notice when today's recording slides and transcript are available on the Solution Center. So thank you, everyone, and have a great day.
Thank you.
Thank you.